Good morning. Today we're going to see the concept of static versus dynamic binding. So connecting a method called to method body is called binding. First of all, we should understand what is binding. So in programming language, connecting the method called to method body is called as a binding. Okay. So there are actually two types of binding. First is the static binding, that is also known as the early binding, and second is the dynamic binding, that is also known as the late binding. So whenever we are talking about the static binding, when type of the object is determined at compile time before the execution of program, that is the compile time, it is known as the static binding. And whenever we are talking about the dynamic binding, so when a type of the object is determined at runtime, so it is known as the dynamic binding. The binding which can be resolved, in short, at compile time by compiler is known as static or early binding. So in Java, the methods written using keywords like static, private, and final methods are resolved at compile time. Whenever we are talking about dynamic binding, in dynamic binding, compiler doesn't decide the method to be called. Method overriding, that is one of the example of this dynamic binding, right? So private, final, and static members, that is methods and variables, use static binding, while for virtual methods, in Java methods are virtual by default, right? In C++, explicitly we are writing the virtual keyword before that function name. So binding also done during runtime based upon the runtime object. The static binding uses type information for binding, while dynamic binding uses object to resolve to bind. So overloaded methods are resolved, that is deciding which method to be called when there are multiple methods with the same name, using static binding, while overridden methods use dynamic binding, that is at runtime. So the point is nothing but whenever we are dealing with the method overloading sort of thing, that terms comes under the static binding, and whenever we are dealing with the concept of the method overriding, that comes under the dynamic binding. Which can also, you can say, that concept of early binding and the concept of uh, late binding. So to brief for this particular slide, binding refers to the process of converting identifiers, etc., variables and performance names into addresses. Binding is there for each variable and function. For functions, it means that matching the call with the right function definition by the compiler. Okay? So it takes place either at compile time or runtime. So based on that, you can have a static binding or the dynamic binding. Now we'll understand understanding a type with respect to this. So first of all, we see variable have a type. Like each variable has a type. It may be primitive and non-primitive. So primitive, suppose integer data, the data is a variable, and integer is data type is equal to 30. So here data variable is a type of integer. Second, reference have a type. Whenever we are having the say class name as a dog, and inside the main function we are creating instance of that particular class dog d1, right? So here d1 is a type of dog, that is the class. Then object have a type. Now an object is an instance of a particular Java class, but it is also an instance of its superclass. So whenever we are saying, say example, class animal, so and we are having class dog extend that animal class. So animal is nothing but the base class, dog is nothing but the child class in this particular case, or derived from this particular animal. This extend keywords represent the inheritance. That means sort of, you can say, dog is an animal type of relationship is implemented using this particular extend keyword. That is actually the inheritance, a single level type of inheritance. So inside this main, we are writing here creating the object of dog as a d1 with respect to that particular class dog. That means for the child class, we are creating that particular object. So that you can say object as a is a kind of type. So here d1 is an instance of dog class, but is also an instance of the animal class. That means whatever the, you can say that attribute that we are specifying in the animal class can also accessible in that particular object of the derived class dog. Now come to the point static binding. So when already we know that it's early binding when type of object is determined at compile time. That is compile time by the compiler only. So it is known as static binding. So if there is any private, final or static method in a class, there is a static binding associated with those particular things. So let's have an example of this particular static binding. Now class dog is there, right? So and for this particular dog, we are having some method, say it, that method is private in that particular dog class. So we are printing something inside that particular method it. And inside this particular main method, we are creating object d1 of this particular dog class, and we are calling d1.eat. So this will going to call that particular eat function, and that is accessible by that particular object of the dog class only. So in this particular case, this is nothing but an example of static binding. That is, method call will get associated or attached to that particular method body at the compile time. Then come to the point of dynamic binding. So when type of object is determined at runtime, so it is known as the dynamic binding. Now thoroughly see the example here. Class animal is there. We are having some function it inside that particular class animal, which is the parent class or base class you can say. We are printing inside that some animal is eating that sort of message. Then we are extending class animal to the dog class. That means dog is a animal. So class dog extends animal, so which is a derived class from the animal class. We are also having the same function name eat inside that particular derived class dog. We are printing that dog is eating. Now we are writing main inside this particular derived class, and we are creating here, just observe thoroughly, object A of the parent class, and we are passing the reference of that particular derived class dog to the object of the parent class, and we are calling a dot it. So it will not going to call this particular it function from the base class. This a dot it will going to call the function from the derived class dog. So it is going to print dog is eating. So this is nothing but object is determined at runtime. That means reference is passed to that particular object at runtime. So it's a dynamic binding. Now let's have overview about differentiating factor between the early binding and the late binding. The first differentiating factor between early binding and late binding is early binding. It is a compile time process. Okay, so before your program go to the run condition, the early binding happens. Late binding, it is a runtime process, as we have seen the previous method. Now, early binding, the method definition and method call are linked during the compile time, whereas in the late binding, the method definition and the method call, they are linked during the runtime only. In early binding, actual object is not used for binding, whereas in the late binding, your actual object is used for the binding. That means the derived class reference you are passing to the parent class object, right? Now, in case of early binding, the example is nothing but method overloading. Now, when you are talking about method overloading, that means a name, you can say in a single class there are suppose name function name, say it, with single parameter, and we are also using the same function name with two parameters. So that concept comes under the early binding through method overloading process. Whereas in the late binding, the example is method overriding. So in this particular method overriding concept, two classes are involved, as we have seen here. That means class animal, say class dog is there. Both the names, function names remain same, each and each here. Only thing is that we will going to override the method of the parent class in the derived class. So that is nothing but a method overriding, which is also considered dynamic binding. And as we are talking about this method overloading, so here just say single class dog is there. We are writing method it. Here no parameter. Suppose we are writing method it with one parameter, say integer a, and again same method name it with two parameters, integer a comma integer b, something like. So that comes under the point of method overloading. Then another differentiating factor between early binding and late binding is that early binding program execution is faster because your method call and method definition are linked together at the compile time only. In late binding, program execution is bit slower because at runtime we're going to link method call and the method definition. Now next important point that we are supposed to study, that is nothing but the concept of message passing. Concept of message passing. Now, message passing is a mechanism by which the objects interact with each other. I repeat, message passing is a mechanism by which the objects interact with each other. Right? So, in object-oriented programming, communication between objects is a vital aspect of building complex systems. So, one of the key mechanisms for achieving the communication among the object is nothing but the message passing. Right? So, this particular message passing allows different objects to interact with each other by invoking methods and passing data bit among those particular methods. So message passing in terms of computer is a communication between the processes. It is a form of communication used in object-oriented programming as well as parallel programming. So message passing, when you are talking with respect to Java, is like a sending an object to, we can say that, object of another class. That is message from one thread to another thread. So it is used when threads do not have shared memory and they are unable to share monitors or semaphores. These are nothing but the parts, or you can say that concept from the operating system or any other shared variables to communicate each other. So in short, you can say this is the sending object, this is the receiving object. So the communication is executed between the sending and receiving object. So through this particular message passing, communication is established between these two objects. Right? That means requesting some information via the message and triggering some method via this particular method. These are some important part in this particular concept of message passing. So whenever we are talking about this particular message passing, it provides an interface between objects and it will help to communicate in a loosely coupled way while keeping their inner complexities hidden. So again, we are adding to the concept of object-oriented programming. Information is hidden from the user, and it's communicate using loosely coupled fashion. So coupling and cohesion, these are nothing but two important parameters in software quality assessment. So when we are talking about coupling, it is nothing but the interdependency among the modules, and cohesion is nothing but a functional strength of a single module. So it is loosely coupled, coupling between the two objects. That means there is an interdependency between two objects, but it is loosely coupled. Interdependency is somehow like that not that much strong. So with respect to Java, we implement message passing using method calls only. For example, you can say when object A invokes a public method of object B. Now object A and object B are classes, are objects of two different classes. So it is sending a message to object B accordingly. So note that object A can only object B's public methods, not its private methods. So that is nothing but the, you can say, some sort of rule. Only you can say that public methods can be accordingly. We'll have a, you can say that, let's have a quick example of message passing. Just see here, class book is there. We are having certain attributes specified inside this particular class book. Then you are having some method display. With respect to display, you are displaying title, author and price of that particular book. Then we are having another class that is called as the bookstore class. So inside that bookstore class, we are having sell book with parameters book and book. What is this book? This book is nothing but the class, and this book is nothing but object of the class book. Right? So here, now what we are supposed to do through the particular sell book method, we are supposed to perform operation to sell the book. And once this particular method will get, we are going to print book sold. That means book dot display details. That also you can say we are supposed to write some body for this particular display detail method. Now come to the, you can say that main class, or you can say that class where you are supposed to specify the main method from which the execution of the Java program will begin. What we are doing here, we are creating the object of the class book, this particular book class, that book one object we are creating. Then we are calling the set title, set author, and set price. These three, you can say that, uh, functions that we are supposed to. These three, you can say that, uh, operations we are supposed to call. So book one dot set title, this set author, and set price. Right. So we are setting that set title in Java programming, set author John do, and set price in 29.99. So you can say that these three we can at values we are set. So through this setter and the getter method. So you can have body for this setter and getter method accordingly. Then next what we are supposed to do, we are creating the object of this bookstore class as bookstore. And then through this object of this particular bookstore class, we'll call this sell book function using message passing. So what we are doing, bookstore dot sell book, and the message that we are passing as the object is nothing but book one. What is this book one? This book one is nothing but the object of this particular book class that we are passing to the object of the class bookstore. So, and what information we are passing? We are passing the information like this title, author, and price of that particular book one. So whenever we are calling book dot sell book one, it will going to invoke this particular function, this to this book sold or sell book one. It is going to invoke this, and it will print book is sold, and you can write the display function accordingly, book dot display details. So this book dot display detail will print Java programming, that is title, author, price of that particular book accordingly by executing this function. So in this particular fashion, the message passing will be perform in object-oriented programming. There are another examples also you can go for this particular message passing. Now, important point when we use message passing in object-oriented programming. First, when one object needs to request data from another object, you can use this. When one object needs to notify another object of an event or there is change in the behavior, you can use this. When multiple objects need to collaborate to achieve a common goal, information sharing is expected from different objects to achieve certain common goal. For example, if you want to print the class of a student in a result analysis, so you require student information, marks information, co-curricular activities. So that can be clubbed together. So when one object needs to delegate responsibility to another object, you can use the message passing. When one object needs to control the behavior of another object, so behavior is one of the important aspects of any object. When you want to control this, you can use for go for the message passing. When one object needs to communicate with other objects in concurrent system, that time also you are supposed to use this concept of message passing. Then look real life application with respect to the message passing, right? So we can say that in a graphical user interfaces, we can use this message passing concept. For example, you can take any, you can say that web-based application where, or any event-driven sort of programming. When we click a button, a message is sent to the button object to trigger an action. So event-driven programming is one of the example that on say click, that is nothing but event. On that particular click event, you are passing some information to the underlying code. Then object can send messages to each other by synchronized activities in multi-threaded application. Like one thread can send a message to another thread to signal that particular task is completed accordingly. And that's mostly in the operating system environment. This message passing concept is very vital. Again, in distributed system, objects on different devices communicate with each other by sending messages over the network. As I told in the event-driven programming, objects send messages to each other to respond to the events like system notification. Like for a button object might send a message to handle object to process click event. There is click event, double click event, or you can say that focus lost. You can say those type of event, form opening event. So that as time also you can use this particular message passing concept. In simulation and modeling environment also this message passing is widely used. Like object represent real world entities, and send messages to each other to simulate the interaction. For example, a vehicle object might send a message to road object to request permission to enter. So that particular immediate message passing or information sharing will happen to this particular message passing to take certain quick decisions. Now let's quickly have a differentiating factor between this dynamic binding and the message passing. Dynamic binding and the message passing. So dynamic binding, you already know, binding refers to linking of procedure call to the code to be executed in response to the call. Whereas in the message passing, this is a process of programming in which communication is involved is known as the message passing. Dynamic binding allows execution of different codes using the same object at runtime. Message passing allows developing communication between objects. Now the uses of the dynamic binding to allow executing different codes using the same object at runtime. In message passing, it involves three basic steps. That is first creating classes, creating objects, and establishing communication among those objects. The next, in dynamic binding, it is the method of linking a procedure call to the relevant code that will be executed only at runtime, as we are talking about dynamic binding. In message passing, it is the method of exchanging messages between objects in object-oriented programming. Now in dynamic binding, the code associated with the procedure is not moved until the program is executed, right? So this is the part of net binding. In message parsing, it involves name of object, the name of the function, and the information to be sent. It is known. Dynamic binding function call associated with the polymorphic reference or depends on the dynamic type of that particular reference. In message passing, communication with an object is feasible as long as it is alive. Again, in dynamic binding, only at runtime the code matching the object under the current reference will be called. In message passing, a message for an object is request for execution of procedure and therefore invoke a function in the receiving object that generates that particular desired result. So in short, dynamic binding occurs during runtime, message passing occurs between two processes. Dynamic binding is also known as dynamic dispatch, date binding, or runtime binding. Message passing is also known as message exchanging. Last, object-based programming does not support this particular dynamic binding, whereas object-based programming support message passing. But whenever we are saying this particular fact, object-oriented is going to support it accordingly. So thank you. That's all for today's session.